Hello everyone, my name is Zachariah Isa and I'm the RVI sales engineer. And today we're going to be talking about how much physical impact the insertion tube of the Olympus Videoscope can take. So here's the plan for today. First, I'm going to be talking about the 4-layer construction of the insertion tube and the function of each of these layers. Then I'm going to talk about the military standards that our videoscopes have been tested for and have passed. And then I'll give some tips and some common practice and things that you should do and things that you should avoid. And finally, I'll demonstrate some examples of the physical impact these insertion tubes can take, and also some examples of the damage that can result from user error. So this is the 4 layers of the insertion tube. The outermost layer is the braided cover made from tungsten, which is strong and durable. And makes the insertion tube abrasion resistant. The second layer, which is glued to the braided cover, is the rubber cover, which prevents the insertion tube from water ingress, making the insertion tube waterproof. And the third layer is the mesh interior for torsion resistance. And the final layer is the taper flex coil for crush resistance, but also maintaining the flexibility of the insertion tube, allowing it to easily maneuver and go through twists and turns. Now, one thing I want to mention is, as you can see in the diagram here, the articulation section, that's the section where the insertion tube articulates, it has a slightly different in the design, where the braided cover and the rubber cover are not glued together. And that's just mainly to maintain the articulation capability of the insertion tube. This, however, makes this section slightly more susceptible to damage, which I'll talk a little bit more about when discussing common practices. So these are the military standards that the videoscopes have been tested for and passed: vibration, shock, water resistance, humidity, salt fog, sand and dust, icing, freezing rain, electromagnetic interference, and finally, explosive atmosphere. Basically, our videoscopes have been vigorously tested for industrial applications. So the most 2 common causes of damage that I've seen based off my experience are the pushing and pulling the insertion tube when the articulation is locked. So locked articulation is just a feature in our videoscopes where when you articulate the insertion tube and you want it to maintain its location or its position, you can press the joystick to lock it. However, if the user forgets to center the insertion tube and unlock it and then retrieves the insertion tube, that can potentially cause damage to the insertion tube, which I'll showcase in my demonstration as well. The second common cause that I've seen is mishandling the insertion tube in general, which can cause the lens to crack, and that's in both the distal end of the insertion tube itself or the tip adapter. Now, if you damage the tip adapter, it's not the end of the day. You can still you can just buy a new one. Whereas if you damage the lens on the insertion tube, it's a lot more costly and most likely would require the replacing of the insertion tube. So just keep that in mind. So some preventative measures that you can take. Always make sure that the articulation section is centered when retrieving the insertion tube. Our videoscopes on the main screen, you can see an icon when the articulation is locked. You can see a scope with a lock icon, basically just indicating that the articulation is activated, the locked articulation. You can center the insertion tube by pressing the center button on the controller, and you will notice the icon disappears. And once that happens, you're good to go and start the retrieval process. Another thing I'd like you to try is utilizing the scope stopper. These are designated locations on the videoscopes where you can put the insertion tube to basically for it to hold its place and not be laying on the ground where other users can come and start walking on it, for example. So it keeps the entire videoscope system, I would say, more compact. The final thing I want to talk about is always consider the environmental conditions and the allowable specs for our scopes. These are just basically upper and lower limits of the optimal environments to use the video scope. So this information can be provided, we can provide that information, and it can also be found on the Olympus website. So now I'm going to demonstrate some examples of the type of physical damage these scopes can take. Let's see what happens. So first I'm going to step on this insertion tube and kind of rub my feet. And I want to see what happens. Let's see. So as you can see, the insertion tube can take that, no issue whatsoever. Let's try something else. I want to try this hammer and see what happens. As you can see, also hammering the insertion tube caused no damage whatsoever. One final thing I want to try. Let's try rubbing this scope onto this aluminum bar and see what happens as well. As you can see, not only is it not damaged, but I can actually see some aluminum residue. So it actually ended up damaging the bar itself. So that's a good thing to see. So basically, these insertion tubes are robust and durable, but if you do subject it to even more physical impact than what I've just showed, there is a potential for it to get damaged, as you can see on this insertion tube over here. So yeah, always practice common care, and even though these scope systems are very robust. And the last thing I want to talk about is I had already mentioned the locked articulation feature. This is a good example of it. You can see that it's about 90 degrees in locked articulation mode, and it creates this L shape. And then let's say if you have a protruding part in the area of inspection and you forget to center the insertion tube and you start pulling, you can see that doing that over a period of time, the amount of friction can end up causing piercing on the insertion tube. So just make sure that you always center the articulation section prior to retrieval. Thanks everyone for your time. And now we're going to have some time for our Q&A.
So the first question we have, it says, where are the scope stoppers located on the video scopes? For the NX, it's located on the lower left corner of the screen. So it's basically a small hole where you can feed the insertion tube into, making the whole video scope system more compact. On the GTGX, it's actually on the controller itself. It's right above the joystick, or the articulation joystick. Let's see if there's another question. So we have another question here. Where can we find the operating specs on the Olympus website? So the Olympus website is www.olympus-ims.com. And then you would see a tab on the upper left corner that says products. Once you go there, you will select video scopes, and then you can specify which model you want to look at. And then once you select the model, let's say the NX, for example, you will see 4 other tabs, and you will click on specifications, and it will detail all the technical information that you're looking for. All right, I don't think there are any more questions. Again, thanks guys for joining us. If you have any more questions or inspection questions, please feel free to reach out to me or your local sales rep, or you can go through our Olympus website at www.olympus-ims.com. Thank you and have a wonderful day.